Hiya guys, and welcome back to Wade's Workshop. So, Webster engine part 2. Can I start off by saying apologies? You will hear me doing lots of sniffing in this video, and you can probably hear it in my voice now. Full of a head cold. It's, part of the nature of living in the UK, that you get horrible colds and what have you. My chest is really tight, so I do struggle to breathe, when I've got chest infections or what have you. So I'm not that well at the moment, but I'm still getting on with it in the shed. So anyway, here's the video. Enjoy, guys. So as you can see, I've got the two sort of main side frames of the engine set up here. Well, I've got one of them set up. There's sort of one's longer and one's shorter. They're going to have a profile on the outside, like it comes along and then it scoops up at an angle, and this one then has the matching angle on it. I'm going to put all the holes in before I start chopping corners off them and doing the outside profile, just because it's easier to hold when they're rectangular. So edge finder at the ready. Let me come around the camera there, get somewhere near. I'll do a bit of a touch lower there. There we go. So I'll just pick up this edge. Now I do have this wobble pin, which it has 100 thou diameter on the end of it. I'll just touch on the edge. There we go. Set a 0 in X. Now if I move over a further 50 thou, I've shown it many times, but for those of you that have just turned up, if I move over 50 thou, and I've just gone a bit too far, there we go, and reset that to 0. That puts the centre of the spindle in line with the edge of there. Don't touch that edge. Right, I'll just pick up this bottom edge now, which is the datum edge. Do the same again. Do the touch till it kicks off. There we go. So Y0, move another 50 thou. And reset 0. No, reset 0. Okay. So my 0 mark is smack on the corner of these two faces, the intersection. So that's done with a wobbler. So let's put that to one side. Drill chuck up now. Put the quill up in the air. Got the drill chuck set up in a collet. Here, ER32 collet. Just tighten those up. Put them in the right hands. Okay. So, first datum, 250 thou up. So bring him across in Y. That's way too much. 250. Lock Y. 375 from this face in. As you can see, I've written on with a Sharpie where they got to go. Say printing out all the drawings. Basically what I've been doing now, I've fallen foul of doing a sketch before now. I take a photo of the page on my laptop, of the page of the drawing I'm working on, and then I can just jump on my phone, bring that photo up and look at the areas, plot down exactly what the figures are. So yeah, the bits of sketches, and hang on, let me just find something, these sorts of sketches I was doing, it bit me, so I've changed tack without having to actually print the drawings out. What I should do is print the drawings out, I know, but I probably will at some stage. So basically this, when it's cut away, is going to bolt onto this face of the head block. The holes I put in here were M4, so 4mm diameter hole. I've centre drilled it already. And there we go. Okay, let's have that back out. So that's the first hole. Undo Y. And my setting now is 1 inch up. 3/4 hole centres. So nearly there. There we go. Second hole. Just bring that parallel back out from under it. Oh, it's tight. Probably could have just used a 4mm spotting drill on this, probably would have been a better idea, but hey ho, done it now. Ooh. We just got enough Z height under there to get that in. Okay, so I'm thinking, I think the drawings show some little countersunk screws in here. I wonder if I can get cap-headed Allen bolts in. I'm going to dig some out and see if I got enough head height to get a Allen bolt in. I think I have. So good news, I do have enough room. So 4mm deep with a countersinking bit now. A counter boring bit, I should say. Need to buy some more WD-40, I've run out. I've just put a little bit of cutting compound on the end. Not ideal. I do actually have some liquid stuff as well. I should probably get that out. Put it on a brush in a pot maybe. Okay. So I think need to tidy that up now, so maybe a little chamfer on the top of that hole. What have I got? Will that do? Don't think that'll fit in the chuck. Oh, you know what? Not to worry. I'll do it by hand. Could probably use an ogre on this as well. Whoops. That did the job. Right, okay, so that's those two. I got another hole up here now. 2.443, ½ inch up. Let's move to ½ inch. And I don't even know what size it is yet, but I can get to the right spot. 2.443. No, 2.433. 2.433. I know what this is. This is the pivot point, I believe, for the exhaust valve lifter. Right, 2.433, and that's not quite, that's 499 and a half. 500 thou. So on centre there. Yeah, the pivot point, there's a rocker here, there's a cam here somewhere, lifts this rocker arm up and down with a spring on it. It might be for the spring, and it's what lifts the exhaust valve as the engine's running. So this is its pivot point. It's a bit slow. Be careful, I don't know what size hole it is, so I'm not going to pop that centre drill right in. Just mark it. Okay, I'm going to go back to my drawing on my phone and see what size hole this is meant to be. Can you spot it? I can. Broken tap. Well, I don't recall the last time I broke a tap. Just getting heavy-handed with it, getting too keen, trying to rush it through. I drilled and tapped it. It was M3. I drilled the hole 2.5, started tapping it, got started, got carried away, and snapped the tap off. Inexcusable. I haven't done it in so long. However, I have not scrapped the part. I could fight with that for probably half an hour trying to get that broken tap out of there. But this plate, even though it's a rectangle at the moment, this piece here is going to be cut off. So if I flip it round the other way, and I can cut that piece there off with a broken tap in it. So, I'm glad I set my stop up now. It means all my datums are still there. So, basically, let's just clean that parallel. So if I set that back up, lock it down there, I can start again and put the two holes countersunk in this way, in this end, and yeah, I'm basically back to square one. So yeah, not the end of the world, but just blinking tap, just annoying. And I'm not sure if I got any more M3 taps. I think that might have been the only one I had left. I've got a set in work, a full set, but I think that's the only one I got here in the workshop. I'm sure I've got one somewhere. I'll have to have a nose about. So I'm still on datum, back in here with that 2.5 hole while I'm here, and I'll have a dig about for a tap and tap him at a later stage. So okay, just mark that. Hey, these things are set to try us. But the handy thing is, well, on this occasion, I haven't scrapped the whole part. You can imagine if it was a last op on a part you'd spent a long time on. We've all done it. I did get my liquid WD-40 out. My little spill pot there. Or anti-spill pot, I should say. That was a gift from, there then, Saw Logs Plastic Hubs seems to come to mind. So if you're watching, I am using the spill pot, and I think even the little acid brushes came from the same guy. So thank you. I'm trying to think of the guy's name. It will come to me. It will come to me. Anyway. I'm getting on. I forget these things. So, back to original datum. And drill and countersink 2 holes for the M4 bolts as it did in the first place, but down here now. So a little bit of good news. My spark plug arrived. So let me show you. In the previous episode I had the wrong spark plug. I had an NGK CR6 and this was the spark plug. So I thought that was a small spark plug. So let me show you something similar. That would be your normal car spark plug-ish size. This was the spark plug I thought was correct. But the CR6 is wrong. It's a CM6 I needed. So CM6 spark plug arrived. Let me open the box and show you how tiny it is. So standard sort of car size spark plug. There she is. CM6. So it's tiny. Yeah, NGK, oh, I don't know whether I can get that in focus or not. But anyway, NGK spark plug, CM6. That's the tiny little spark plug that's going to be used in this engine. So that's arrived. Now, I did think I had the correct tap to tap the hole for the spark plug. So I saw, I didn't even look at a Zeus book or anything like that. I saw that the thread size, and in fact the baby little one, it's the same thread size as the small spark plug I had, is M10 by 1. And I thought, yeah, I've got M10 fine taps, I've got a set of them. M10 fine is not M10 by 1, it's M10 by 1.25, I believe. Standard M10. M10 coarse would be 1.5 mil pitch, I believe. M10 fine 1.25, no, 1 mil pitch. So more good news, M10 by 1 mil tap. So I now actually have a tap that will do the job. So great news. So I think I'm in the middle of that plate at the moment. I'm going to finish off a few other details of that and then move on and finish off, where is it? I think it's in this box somewhere. Oh, no, I put it away. I keep putting things away. There it is. I'm going to finish off doing this block. So it's going to need, I'm guessing, a 9 mil hole drilled through there, and then I can tap it with the M10 by 1 tap. I've just placed the 2 little screws that I'm going to use. You saw me drill the screw holes twice, as it happened. You know, one set in the wrong place. Well, they were in the right place, but I broke the tap. It's been one of those days, guys. So anyway, I've got bolts that will work. So that's good news. So let's move on. So when we left off, I drilled that hole, snapped the tap, flipped it over, put 2 new holes down here. This was going to be M3. I'm going to do a bit of a redesign. It's now going to be M4, so I've just drilled that out with a 3.2 drill. So let's move on to the other holes. So another hole, 4.460 up from the end, and 910 thou. In fact, we've just seen that's 911. Let me just pop it back again. 4.460, like 9. Going the wrong way. 10. So, set the drill. Now, this hole, finished size, quarter ream. So, what I'm going to do is a 6mm drill and then ream it with a quarter reamer. But what I need to do is make sure I've got a quarter reamer first of all. So the good news is I do have a quarter reamer. Back from the S50 days. So that's a 6mm drill. Just make sure that parallels out the way. So this is for the camshaft, I believe. Yes, it is for the camshaft. Now the camshaft, yeah, okay. I'm thinking about having the camshaft running on a needle roller. Take a head up a spot. Okay, I'll have to get a needle bearing with a quarter. Okay, but not the end of the world. So that's a little bit fast. That's about right for quarter. We're running at 300 RPM. Quarter reamed hole. Okay, I'm going to leave it there. Right, that's that hole done. Now, big end, or one of the big end, or let's call it main journals. Crankshaft main journals, we'll call it. So up here, it's 2 inches up, so move up in Y to 2 inches. Right, this is going to have to be really accurate, so I'm going to be really careful on my DRO. Locked. And 4.750. So bumping the tripod. Handle is bumping it. 730, 740, 749, 751, 4.750. Okay, so my thinking here is I may put bronze bushes in. I may put I'll bring the head down. And I may put copper bearings in it, deep groove ball bearings. I may. We'll see. But what I'm going to do for now, just to give the datum, is again I'm going to put a quarter reamed hole in. Reamed hole in. Okay, so quarter reamer, and that gives me at least gives me a datum relating to everything, and then at least I can pick that back up later, clock in a dowel or whatever I do. And gives me options when I move forward. think the crank, I'm not sure. Ooh. No. Thought it hit the parallel then, but it hadn't. It gives me options moving forward. I mean, I think the main crankshaft, not sure without looking at the drawing, it's either 5/16 or 3/8. But I may go 8mm, I may go 10mm, you know, piece of drill rod, 01, something like that. But it gives me options for bearings if I can change the main shaft diameter. I'm sure I can get some bearings that'll go in there. So originally it was designed to run straight aluminium, but bronze bushes would be better, brass bushes, bronze bushes, but I may put bearings in. We'll see how it goes. So as you can see, I've set it back up the other way. I've had to put a parallel in here because I've got a bit of broken tap sticking out in the bit that's going to be cut off. So this is the bottom of this plate. Now it's dimensioned weirdly. It's dimensioned from the centres of these holes at 3.625 for the first tapped hole. This is what clamps this down to the base plate. M5s I'm going for this. But these were 0.375 plus 3.625, so 4-inch. So I'm still on the date. I'm on my pin on the end here. So I can come 4-inch. I picked up the centre this way. So I'm looking at setting this at 4-inch for the first hole. So let me just get to that spot. Now I'm going to be doing the holes in the base accurately with a DRO. 3.99960, that's close enough. So, first hole, let me go with there. And then it's 1.125 further on. So it's the last time I'm going to need this datum. So I'm just going to set X as 0 and then 1.125. Inch and an eighth. It's quite strange the way people have commented that I work, I sort of talk in thou and metric and everything at the same time. So when I served my apprenticeship many years ago as a greenhorn, 17, 18-year-old, everything was imperial. Didn't believe in metric back in those days. But then 4 or 5 years later, everything was metric. Depending on the sort of industries you're working on, I served my time with a British company, well-known filter manufacturer with orange filters. Could be confused with people who make barrels. So I served my time with that company. And of course, everything went to sort of European specs and what have you. There were a lot more European cars and everything went metric. So, yes, I've learned in both, I think is the truth of it. So, let me just see, M5 4.2 drill. There's nothing down here, so there's no reason why I can't go a good 20mm deep, won't hurt. Well, that's right on the surface there. Let me just wind up a touch. I'll go to touch, set a 0. I'll go 20mm deep with these, give myself plenty of threads. I know I've got M5 by 25mm bolts, so saves me cutting bolts. That's 10mm deep. So yeah, that's why I can sort of, I'm going to go 18 deep, that's more than enough I would have thought. I will go 20. Blow it, won't hurt. Now 5mm hole, 20mm deep, and then back to my 0. That's just above the surface there. And that's it. well out of the way of the cam spindle there. $20 deep. Okay, so they're going to be M5. I'll just check my drawing, make sure there isn't one up the other end. There could well be. Would I like to put one up the other end? You know what, it's held down here where the crank goes in. It's held down in this end by the cylinder head. Don't think it needs one. No, let's not overcomplicate it. I'm going to leave it at that. So while I'm sort of set up, I thought I'd just as well do the holes in the bottom of this, as I've got all the right drill bits out and what have you. So there's the edge, X0. So, first hole, 500 thou in, so 550. Oh, let me come round. Okay, let's just lock that. Set X0. Okay, so I'm already centralized this way, so I thought I'd just as well whack the hole in while I'm at it, or whack the two holes in. So back in with a chuck. So again, centers are the same, 1.125. I'm on a 0 datum there, 500 in from this end. I went to 550 because of half the ball thickness of the wattler. Center drill, and we'll do this while we're at it. So it's the same again, guys. I'm sure you don't need to see it, so I'll leave it at that. So there we are, 2 holes drilled, 4.2mm, ready to accept the 5mm tap, 20mm deep, not going to get in the way of anything. So yeah, I just thought it made sense to do it while I was already set up in this direction. All I had to do was pick up a 0, do the holes. So I was feeling particularly brave, and I just power tapped the spark plug hole, M10 by 1mm. So there's a spot face to go in here. Now I'm not sure. I think it's 3/4, 15mm deep. I'm tempted to leave it because I don't know how much the spark plug's going to stick out, whether that was considered in the original drawing. So I'm not going to spot face it. Not at this stage. I can at a later stage. That's easy enough, isn't it? But yeah, I'm not going to spot face it. So we have a tapped hole there. I can always deburr it and run the tap back down through, but yeah, that's the spark plug hole. So let me just try. Have the spark plug. It needs deburring, obviously. Okay, well that's sweet. So the spark plug's going to go in there. Yeah. Right, let's put that spark plug safe. It ended up costing me £6.99 online. So £7 for a spark plug. Cheap compared to a car one, but quite a lot for a little dirty thing. So I'm going to throw a question out there. I'm at the point on this block where it needs the spot facing in there perhaps, and it needs a 250 thou radius on these top 2 corners. There's a plate going in here, as well. That's the plate with all holes in, which just made, which is going to have that step cut in it. So I'm thinking, do I radius down here, across the top, down here, you know, follow the radiuses on, or radii. There won't be anything on the front because the cylinder is going here. No need for anything on the bottom, and I don't think this edge, break edge, will do because the cylinder comes right to the outside edge. So I could, right, the question, I could file these radiuses, radiuses on here and make a neat job and file everything and make it look all nice. Or I could get it on the rotary table and machine them on and have them perfect. So, okay, the question is, do I make this engine to work it's going to work, whatever, or do I go the whole hog and make it look beautiful? So I think the drawing calls for blue anodized on on all the aluminium parts, or several of them. I'll probably blacken the cylinder. It does say black paint, but I'll probably just blacken the cylinder anyway. I may do it with like VHT paint or what have you. But do I make it look absolutely beautiful, or do I just make it so that it works? I know which way I want to go, but you guys tell me, what do you think I should do? Obviously, I'll show the machining of the unit, get it to a point where everything's complete, and then I'll spare you the beautification, as it were. But obviously, if I'm going to be doing the radiuses on here, on the top corner, I may show that anyway, how I do the radiuses. I keep saying that, radii. Or do I just file them on to a scribe line? You know, what do you want to see? Mechanical or hand fitting? The mechanical I tend to go for. The hand fitting's fine, I can do that. You know, I do have the patience for it. Like a doctor with many clients, I have the patience. So, anyway, let me know, guys. Tell me what you think. Just thinking after that clip, I've never anodized anything in my life, but I've seen how to do it on the internet. So maybe that'll be something new, learning how to anodize. I probably won't anodize the finished parts if we do go down that route. I'll anodize, you know, some scraps first and see how I get on and get the principle and the practice right. But anyway, so there is that. Maybe going forward, anodizing would be a good thing. I mean, my little stop here, that would benefit from anodizing. In whatever colours or what have you, but yeah, so anyway, that's just a little thought in the background. Well, here we are, guys. I think that's about it for this one, so apologies once again for the sniffing and stuffy headed voice that you've heard during this one, but it is what it is and we get on with it, don't we? Anyway, I'd be interested to see in the comments what you guys think, which way I should go with this engine. Do I make this absolutely beautiful thing that's all anodized and gleaming, or do I just make a working engine? So yeah, I will go with the consensus and we'll see how that comes out. Anyway, guys, thank you so much for watching. As usual, thanks for subscribing, and we will see you all very soon. Cheers now.